This is just a quick video to explain some of the items I'm using in my automated sort of grow house. What I've got here, it's Arduino release 3. That's the microcontroller I'm just using for this sort of demonstration. There's a sensor on here which is a DS18B20 temperature probe, and what I've got here, I've got a little relay. It's just a 5-volt relay, and that's going down to a 12-volt power supply which I've made out of reclaimed laptop batteries, and then I've doubled that up with these Wago connectors there, and I've got two fairly low current PC 80mm case fans. So what I've done here, I've set this temperature probe on the program on the Arduino to activate the relay at 26 degrees Celsius. So once I'm just holding the end of this, so just that's going to warm it up gently. And you can see when the green light comes on, there'll be a click when the relay activates. That's energized. You just come on and let go of the temperature probe now, so it starts to cool down. And then you can see the fans are spinning up to speed. So what I'll do is I'll just hold the temperature probe just in front of the fans, and that will cool it down. Keeping an eye on the green light there. Don't know what temperature is it at. I haven't got a serial monitor on here. I haven't got an LCD to display what the temperature is, but that should cut out shortly. So the fans are still spinning. It's actually quite warm. Yes, it's clicked, it's gone off. Fans are spinning to a stop. They've stopped. And then if you go back to the relay, the green light's gone off. So if I hold that again, click on, clicked on, and then the fans are come up to speed again. So this is what I want to do is, this is the reclaimed acrylic I'm using for my I call it a grow house. It's a combination of between being a cloche and a full-size greenhouse. I wouldn't call it a greenhouse. I kind of think it's a little bit too small for that, but I'd really use it for propagating plants. But I really quite like the idea of this being automated. And I'll just hold the temperature probe in front of there so it cools down. And you can see the green light at the same time. Just again lifts them out. Click. That's it. Fans have gone off. So I quite like this technology. It's affordable, and it's cheap enough to be kind of mess about with and learn from without having to have lots of investment. Another thing I'm using is these little tiny bootlace ferrules on the ends of the cables, and I'm using these. I've got a box somewhere. I've got to find it now. Just these little Wago connectors, and what these are, they're quite nice. They've got these little lever operated sort of cam lock cable. I can't do it one-handed. They are quite tight. Basically they hinge up like that. You put your little bootlace ferrule in there, and then that snaps down. That's a real positive hold on that cable, and because I'm using quite small leads on these, I've put the bootlace terminals on there. It stops the copper from being damaged, and it makes it so much easier to sort of prototype and put the cables in and mess about with them and change it over and change software and things like that. I don't actually have the details on the top of my head for these injection molded battery connectors, but these are a nice idea, and I'm using these from reclaimed laptops from where I work, and I've just tested all these batteries out, and I've found the ones which are a sort of similar matching sort of amp per hour. I've got a little battery sort of what do you call it, a battery BMS, is it, battery sort of charging board, and that balance charges all these cells. These are lithium ion, and you can see you've got little nickel strips there just to make a combination of however many cells, and to get the amperage you're running them in parallel, and to get the voltage you kind of run them up into series. So 1, 2, 3, 4, 5, 6, 18 cells here. I'm not sure what the ampere hour of that is, but it's quite good. I've got, once again, I've got a little that's just soldered on here, and I've got some sort of spade terminals on there just to make the connections on there. So I'm quite pleased with these. I've got a heat shrink sleeve to wanted to make some end caps and then heat shrink those so they're nice and solid, because you've always got a chance of shorting out a battery like that when you've got the open terminals. But these are quite good fun. Once again, you get a laptop, one of the cells is dead, it won't actually charge up. So you split open the battery molding. You can test all the cells. I've got a kind of balanced charger that gives you a sort of discharge cycle, and it charges them up, so it shows you how many amps the battery is giving you. But these are good for electric bikes and electric scooters and things like that. If you can find electric bike batteries, you can actually strip those down and get all the good cells from those. You can obviously buy them, but I like the reclaimed aspect of this, and it kind of fits in with my ethos and what I'm trying to do. Play around with this technology, but not having to invest lots of money into it to try things out, which is always good. So they're little Wago connectors, and these are good. Traditionally I'd be using these little chocolate box connectors, and they come in a long strip, and then you just cut off what you need, and then you've got these little brass sort of grub screws that screw down into the terminals. Problem is, if you just use just copper cable, and if you've got small terminals like this, that probably is going to go to the side of the screw and fall out, and if that was just copper without a terminal on the end of it, it would tend to sort of break the copper, and then if you solder wires together, it creates a sort of stress, and it fatigues and tends to break. So temperature probes I want to use for monitoring the compost heat as well. So I might set that up with a sort of serial feed, and then do something clever with that to process the data. On here as well, this is just a 12-volt solenoid valve. So likewise, what I could do, similar to with the temperature probe, I could have a float switch on there to operate rather than operating the fans, I'd open up that solenoid, and if this was connected to a water butt, which was elevated, then you'd have a pressure of water, and then that would maybe fill up a reservoir for a wicking bed or a sort of capillary tank or something like that. I wouldn't really want to use this with mains water. The problem is with mains water, it's chlorinated. You get lime scale as well, so I'm trying to use rainwater and harvesting rainwater. And if I do use mains water, I'll tend to sort of leave that in a container, so it allows it to the chlorine to sort of off gas a little bit as well. The other thing I'm kind of looking into is doing oxygenating pumps on reservoirs and things like that to keep water fresh. But that's a smaller battery pack there. That's just 12 volts or roundabouts. And I've got some heat shrink sleeve just over the cables to the fans. I've got to put a little finger guard on that one that stops the plants from going in there. On the outside of this, you can just see I've got a little, just a little rotating vent, so I can close that up in the winter. In the summer I need a little bit of ventilation, so I'd always leave that one open. This one I wanted to get a couple of relays set up, so at the moment it's got a rubber washer to give it some friction, but I take that off and just put a bearing in there. I want to put a small motor, which I can find if it's haven't hidden it away. So this motor is a stepper motor. You can use a stepper driver to control that, and it notches around I don't know, so many so many notches per rotations, and you can basically count the number of steps. So you could actually control that by just turning it a certain number of degrees, full open, fully closed. You've got intermittent positions on these, but I think personally either open or closed is sufficient. This motor is out of an old VCR. That's the tape loading mechanism. But what's quite nice about this is it's got a little slipper clutch on the gear here. As you can see, you can feel some resistance on that. So what I was thinking is making an indent, cutting this out with an indent on here, and putting a stainless steel shelf support, like a little dowel pin through there. So then that acts as a limit stop. So when it hits one side, that's fully closed. When it comes around to the other, that's sort of fully open. What I wanted to do here is cut one of these out with some little gear teeth on the outside, make a little spur gear to fit on this. I might 3D print that or laser cut it. Then I can mount that motor so it rotates through, and then based on the temperature, the same temperature that operates these fans, that would power that motor for a certain amount of time. So maybe you could actually fine tune it, so you might take a second, 1 and 2, then it would hit the limit stop, and then because it's got that slipper clutch, it would just wouldn't go any further. So it just hit that and then it would just slip. But you wouldn't want to run it for, I don't know, 10 seconds or something. You just have to, just a little bit of trial and error. And then I think that would be a nice way of ensuring it's fully closed or fully opened. And what I put is maybe a little bushing or something inside, so that there's no resistance on that, so that it would just be spinning it round. And this has got a, it's so small I can't see it. It's got a little brass gears and a little motor there, so there's a lot of torque to actually turn that. So there's no way once it's powered off, it's not going to slip round. I've got also motors with a little magnetic encoder that counts the number of times it actually passes. So it's about 18 steps per motor revolution. So you can kind of feedback where the position of the motor is. But that's more for the sake of just learning about how to use the microcontroller to control these, and as opposed to just something practical. I thought this was quite an easy way of doing it. Obviously, just with a little gear teeth, you can just flip that open and closed, and then I'd have to make some sort of mounting plate. This one's got a sort of right angle fixing on it, unfortunately, so, but there are tiny little screws in there, so I'd have to just adapt something so that fits through, and that would just drive open, closed. So that's what I've come up with so far. I think it's quite an interesting concept, an interesting project. I just really want to get as much of this sort of technology in here as I can, just for about learning about it and applying this technology. Obviously, this is a small grow house, but these kind of control and systems would be just as relevant to a larger greenhouse or even a commercial greenhouse. So there's lots of that can be gained from doing this on a small scale. It's just, once again, it's affordability. It's using the reclaimed acrylic for the grow house itself. And the laser cutter that's supplying this material, he wants to support the project as well, which is really encouraging. And so I'm going to get him to send over the CAD files for this, so he can kind of laser cut the parts, and then I'll put those together and deliver those to the school, along with some of the sort of tutorials and information about how to program the controllers. There's also like a Raspberry Pi. I've got a M5 stack, which is a different kind of system. Even microbit you can play around with, but I quite like the idea of monitoring the data as well, so you can have information about the vent positions, open or closed, temperature monitoring, humidity you can monitor as well. What would be really terrific is if you could kind of combine this with something like a weather station as well, because then you could actually track rainfall and average temperature, and you could actually have some really good data. The other thing, I'm looking at alternative sort of sources of power. So with the batteries, that opens up scope for solar power and making a little solar panel, and just having this as an off-grid setup as well. I'm using the Arduino because it's low power, but obviously if you're going to be running fans, there needs to be a reasonable sort of wattage of solar panel. So I'm going to set this up with a 100-watt panel, and I don't know, I might use a leisure battery or something like that. I don't really have quite enough laptop batteries to kind of store that power. But this is a terrific sort of as a demonstration as it is. I've got the BSP fittings to thread onto this, and some, I think it was leftover HDPE pipe as well from a building job. So yes, it's going to be good. What else? Yeah, so I'm really trying to get the serial feed from the Arduino and then look at sort of online data logging and things like that as well. Well, that's what I've come up with so far. It's looking quite encouraging. Once again, thanks for watching.